video, I'm gonna talk about controlling the IBGP mesh size. So why do we need to have an IBGP mesh topology? We need it when we have a topology like this. Routes received from R1, R2 can forward routes received from R1 to R3, but R3 cannot forward routes received from R2 to R3 because routes received in the same AS cannot be forwarded into another router in the same AS. That's one of the ways BGP uses rules that BGP uses to prevent loops. So we can actually you actually need to have an IBGP mesh topology for R3 to forward routes or R2 to forward routes to R4. We would need to have a neighborships between R2 and R3. So that would be IGP. That would be a full mesh topology. So, but when we have a full mesh topology, we can have a lot of neighborships, which is not very scalable. So we would need to use something called route reflectors. That's what we are gonna talk about in this video. So as you can see here, solution one is route reflectors. There is another solution which is configurations. I'm going to talk about configurations in the future video, but for now let's just talk about route reflectors. So route reflectors, most popular because they are easier to deploy, easier to design, easier to manage, and the key concept that we really need to remember is that clients do not know that they are clients, and you would just need to configure route reflectors. The configuration is only done on the route reflector itself. So in this case, we're gonna talk about this topology a little later. The route reflector here is R3. RR stands for route reflector. And yeah, let me just explain what the topology here. So we have AS64-200, and R1 is in that AS. It's got a loopback IP address here, loopback interface and IP address, and it's connected to R2 via eBGP. So their peering is eBGP, and R2, R3, R4 are inside the same AS number. So AS number is 64-400, and they have IBGP peerings, and of course each link has their own IP addresses. So like I said earlier, we're gonna configure this cluster here. This is called a cluster, and R3 is called route reflector, and R2 and R4 are called clients. And again, route reflectors, configuration is only done on the route reflector itself. So in this case on R3. Let me just delete this. This is this, and this is R3, right? This is our sorry about that. This is R3 configs, right? There you go. So R3 is the route reflector. So let's just talk about the configuration. So we just need to go into router configuration. I mean, router BGP configuration. So router BGP 64/400. This is our local alias, and this is how you would make your neighbors as clients. So in this case, neighbor is 201.0.12.1. This is the IP address, and this is how you would make that neighbor as a client, route dash reflector dash client. And another neighbor is this neighbor, .6, so 201.0.12.6 route reflector. And of course, this is just the actual the actual route reflector configurations. And of course, you also need the other configurations like the network statements and other neighbor statement configurations. But I'm just showing here the route reflector configuration itself. And note, so like I said earlier, configured only on the route reflector. So once we have configured, once we have made this configuration on R3 can reflect the routes that it learned from R2 to R4, and vice versa. When R4 sends routes to R3 can forward those routes to R2, so problems are solved. So yeah, that would be it for route reflector. Like I said earlier, I'm gonna make a video about configurations on the next time. But for now, thanks for watching.